In this video, I'll be introducing you to data cleaning with Python. Make sure you stay tuned to the end because we are going to be working on a data cleaning project together. Data cleaning is the process of converting data into a format which is useful for effective and efficient analysis. It usually involves identifying and treating missing data, changing the data type, deleting unwanted rows and columns, and characters. Let's take a look at this simple table. It has 4 columns and many rows, but the question is, can you identify things that require cleaning in this table? There's a simple way to do it. We inspect the headers and each column one after the other. Now the header has letter cases that are different from one another. That is the first observation. We need to regularize this when we are cleaning this data. Now we are going to look at the ID column. The records in this column are of different formats. We have this format and we have the other format that looks strictly like integers. We move to the course column. In the course column, we also note that we have same records with different spellings. We also need to fix this in our data cleaning exercise. Now we also look at the enrolled column. In this column, we have non-numeric characters, we have no entries, and we have rows with a mix of numeric and text characters. In Python, we can convert these raw data sets into these cleaned data sets using the Pandas library. Please check Pandas website to read more about it. As stated earlier, we'll be working on a data cleaning project together, and I've downloaded the data set from Kaggle for this purpose. Let's examine the data set. Not to worry, I will include a link in the description where you can actually download these data sets and also complete this project alongside me as I'm doing it. Now you want to see that this data set is about laptop prices. It shows the brand of the laptop, the type, the screen resolution, and so many other information. But before we get started, let's look at the project architecture. We'll be loading our Excel into Pandas data frame, and we'll be converting the raw data frame into the clean data frame. After that, we will export it into a CSV or XSLX file, and we'll be doing all of this in the Jupyter environment. This is the Jupyter notebook where we are going to be writing all the codes. I've pre-populated it with some basic codes just to give us a head start. And then we have the exercises 1 to 10, which we are going to be performing later on. The first thing I want to do is to import Pandas as PD. Okay, I'm just going to run this code. Then I'm going to use pandas.readcsv to load our dataset into Pandas data frame. Typically, this command requires you to pass the file path and the file name, but I can get away with just using the file name because I have saved the dataset in the same folder as this Jupyter notebook. Okay, so I'm just going to run this code now to load our datasets. Then we can view what we've loaded using calling the data frame or using the head or tail methods. I'm going to show you the difference between these three. Firstly, let us just call the data frame by just typing df. Now you can see that we have our dataset loaded into Pandas data frame, and this shows the top 5 rows and the last 5 rows of the data frame. If we use just the head method, we're just going to see the first 5 rows. Okay, let's run this. Now you can see we just have the first 5 rows of the data frame. And if we use the tail method, let's run that. We're just going to see the last 5 rows. I'm using Windows, so I'm using Command plus Enter to run my codes. Alternatively, you can click the play button on your Jupyter notebook. Now let's check the shape of this data frame. This will just show us the rows and the columns. You can see that we have 1,303 rows and we have 12 columns in our data frame. We can also review information such as data type of each column and the number of total number of entries, I beg your pardon, using the .info method. As I've run this now, you see it shows me the number of total entries, the column names, the number of entries in each column with non-null, and the data type. We have 2 floats and 10 objects, and also shows the memory usage. Okay. Now I want to check for columns with null values or no entries, and I want it to count the number of null values. Okay, so I'm going to run this code. Now, as you can see, each column has 30 entries with null values. The next thing I want to do is to inspect each column. What I aim to achieve is actually to check for the unique entries in each column and the number of times they occur. This can also show me some unwanted entries that I need to remove later on. So I'm going to try it on the first column, the company column. You see, when I run this code, it shows me all the unique entries. Lenovo occurred 290 times, and so on and so forth. There's nothing unusual about this column, so I'm just going to go to the next column. I'll comment this out, and then uncomment the type name column around it. Same with these two. These are just the different types of laptops. Nothing unusual about this. Netbook, workstation. Okay. So I'm going to comment this out again and move to the next column, uncomment it and run the code. Now this gives me the different inches and number of times they occur, the screen size. Now there is an unwanted character here that occurred once. I'll need to correct this later on. Let's move to screen resolution. Resolution also looks fine. Okay, let me see. CPU looks fine as well. Let's go to the RAM column. RAM column, nothing unusual, looks fine. Okay, let's move to memory column. Memory column, oh, there's also a question mark on one of the entries. We need to correct this. Then the 1 terabyte, there are some that are written as 1.0. I think I can count 1, 2, 3, 4. So I think we just need to regularize this, make this 1.01 just like the rest. Okay, so I've noted that. Yeah, let me check the GPU column as well. I think this looks fine. Operating system column, look at it. Looks fine. Okay, but Mac OS X, I think it's the same as Mac OS, so I think I need to replace this with Mac OS. So I've noted that as well. Now, what about the weight column? This weight column, I think I'm going to remove the kg at the back of each of the entries and maybe add it to the header in bracket. Okay. I'm also need to change data type maybe to float. Okay. Let me check the price column lastly. Price column looks fine. All right. Now the next thing we want to do is to start working on the exercises. The first task is to drop the unnamed column. The second one, replace the question mark with null. Third one, change the data type from object to float. Fourth, replace question mark again. The fifth one, going to replace every occurrence of 1.0 with 1 in the memory column. Sixth one, I'm going to replace macOS X with macOS in the operating system column. Seventh, I'm going to remove the kg from each of the record in the weight column. Then task 8, I'm going to update the column headers. I'm going to change their names. Then task 9, I'm going to drop every row without price. And 10, I'm going to export the clean data set to a CSV file. Let's jump right into it. Task 1, I'm going to drop the unnamed column. Df dot drop. Then I'm going to specify the name of the column. Unnamed full colon 0. I'm going to say the axis is 1 and in place equals true. We set axis to 1. This one in place equals true. Okay. Now let me check for the columns to see whether we've dropped that. Df.column. If I run this now, yeah, so you can see that the unnamed full colon 0 is no longer part of the column names. We have the other 11 column. Okay, so let's move to task 2, where we are going to be replacing the question mark with null in inches column. Now I'm going to have to specify the exact column I want to perform the task on. So I'm going to say df inches, that is the inches column. Then I'm going to apply the replace function on it. Replace question mark with np.nan. So I need to import numpy as np for me to do this. Let me set in place to true. Then I need to import numpy as np. Okay, so this is going to replace the question mark with null in the inches column. Okay, so I'm going to run this now. And then I can check whether there is still the question mark as an entry in this column by applying the value count on the df inches. So let's do df inches df inches dot value underscore count. If everything is fine, then there should not be question mark there anymore. Okay, so as you can see, it's no longer there. The entry has been removed, replaced with null. All right, let's move to task 3, where we need to change the data type of the entries column from object to floats. df entries, then as type dot as type, then I specify the data type I want to change it to, which is float, and run this. Now you can see that the data type is float. Okay. Let me specify that this is task 3. All right, so we're going to move to task 4 now. For task 4, we asked to replace question mark with null, similar to what we did in our task 2. So I'm just going to copy memory, then df memory to replace question mark with mpnan. Now I'm going to set the in place to true to make our change reflect in the data frame. Okay, I'm going to run this. Then I'm also going to do df memory dot value count to see whether the change has truly been effected. Dot value underscore count. Let's see. Yeah, as you can see, the question mark is no longer there. Okay, so task 5. In the memory column again, we need to replace every occurrence of 1.0 with 1. If you check this memory column, you can see that we have 4 occurrences of entries that has 1.0 instead of 1. This is the second one, the third one, and this is the fourth one. All right, so let's fix this. df memory, you should know the command by now, dot replace. Then I'm going to put all the entries I want to replace into a list. So let me go copy them one after the other. To copy this one, yeah, this is it. 1.0 terabyte hybrid. Then the second one, where is it? Okay, yeah, 1.0 terabyte HDD. Then the third and the fourth are right below it. Then the last one, yes. Then I will replace this list with another list. I'm just going to copy all of these elements in this list into that one and then just delete the dot and the 0. I think that'll be faster. Copy all the elements, paste it. Yeah. Okay. Then I'll set in place to true. And I'll run this. And also use df memory dot value count to check the changes. Df memory value counts. Okay, so now we can compare the memory column before with the after. Okay, so let's check just the first two that we changed. 1.0 terabytes now is now 1 TB, so that's been fixed. Then this one, you can see it's no longer down there, but it has been added to 1 TB ADD up here, which is now 218 entries instead of 217 that was before. Okay, so let me label this appropriately. This is tax 5. So we move to tax 6. For taxes, we want to replace macOS X with macOS in the operating system column. So by now you should know what I'm going to do. I'm going to call that column and then say dot replace the string I want to replace with a new string. Then I'll set in place to true. So this will fix it. Let's move to tax 7. What's tax 7? Okay, tax 7 says I should remove kg from each record in the weight column. So for this one, I'm going to use the strip. I'm going to use dot strip. So tax 7. So I'm going to also call the column. I'm going to say dot str dot strip. So what I'm telling it to do is to strip that every entry in that column of the characters kg. Then I'm going to assign this back to the column equals yes. Okay, I'm going to run this. Then I can move to tax 8 now. Tax 8 wants us to update the column headers. All right, so I'm just going to copy all of these names because they are long. I can't begin to type them. Then I'm going to say df.rename because I want to rename the column. Then columns equals all right, curly bracket, then I paste. Then for each of them, I'll start specifying what I want to change them to. All right, just going to do that quickly. Then I'm going to delete all of this, and then I'm going to close the curly bracket. Okay, then don't forget to set in place to true. In place equals true. I'm going to run this. Then we can check if it has truly been changed. Now you can see that we have new column headers. All right, let's move to the next task. Task 9 wants us to drop every row without price. We're just going to do that. So for this one, I'm using drop NA. I'm setting the subset to the column, which is price. Then the axis, I'm going to set to 0. Axis equals 0. Then in place equals true. Run this. I can also check by using our isNull.sum to see whether there is still any null entry in the price column. isNull.sum. Now you can see that the price column has no null entry anymore. All right, I'm going to comment this out. Then because I've deleted the entire row, so I'm going to reset the index. df.reset_index. I'm going to set drop to true, and in place equals true. So this is going to reset our index number to follow the number of rows we have in the data frame. All right. Now the next task is for us to export the clean data set to a CSV file. But I think before we do this, we should take a view at what our data frame looks like now. So df, now you can see our data frame is looking clean, right? The headers, the entries, and now we just have 1273 rows and 11 columns because of the column that was dropped. Okay, so let's export this to the CSV file. I'm just going to say df.tos_csv, and I will specify the name of the new file. I'm going to use clean dataset underscore laptop price .csv. So this is going to export the clean data frame into a CSV file and store it in the same folder. Now you can see that it's in this folder where we have a Jupyter notebook. Right, so I'm going to open this. Let's check it in this Excel file. Now, this is our exported CSV file. You can see it's looking good, better than the raw data sets, and this can now be used for further analysis by the analytics team. If you have made it this far in the video, I really want to appreciate you. What I'm going to do is I'm going to include a link to my GitHub where you can download this folder. The folder will include the raw data sets, the clean data sets, and the Jupyter notebook where you can find all the codes. Thank you so much for watching this video. I'll see you in the next one.